Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the quadratic inequalities practice questions. If you need any extra help on quadratic inequalities, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 378, there's a dedicated video tutorial there on quadratic inequalities. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so question number one. Question number one says solve the inequality x squared plus 6x plus 8 is less than 0. So to solve a quadratic inequality like this, what I'm going to do is I'm going to sketch the graph of y equals x squared plus 6x plus 8. So I'm going to sketch that quadratic to begin with, and then I'm going to find out when that quadratic is less than 0. In other words, when it's below the x-axis. So let's sketch the quadratic. So let's draw our x and y-axis, so our x-axis and our y-axis. And it's just a quick sketch. It doesn't need to be drawn perfectly. And we're going to label them x and y. And to sketch this quadratic, what I'm going to do is I'm going to find where it crosses the x-axis. And to find where a graph crosses the x-axis, you let y equals 0. So we've got 0 equals x squared plus 6x plus 8. We're going to factorize this, hopefully. It's a non-calculator question, so hopefully it'll factorize. So let's factorize it. So bracket, 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 an x in the front of both brackets. And we're looking for two numbers which multiply together to give us 8 and add together to give us 6. So I'm thinking 2 and 4, so 2 and 4. And if we expand our brackets, x times x is x squared. X times 4 is 4x, and 2 times x is 2x, and adding them together would be our 6x, and 2 times 4 is 8. So that's fantastic. Okay, now we want to find whenever it's equal to 0, so we want to make each of the brackets 0. So for this bracket, x would be equal to negative 2, and for this bracket, x would be equal to negative 4. So this is where the graph will cross the x-axis. It's going to cross the x-axis at negative 2 and negative 4. So let's sketch the quadratic. So it looks something like this. So it's going to cross at negative 4 and negative 2. So negative 4 there and negative 2 there. Okay, so we've sketched our quadratic and we've found where it crosses the x-axis. Now we want to find when x squared plus 6x plus 8 is less than 0. So we want to find which values of x, when if we substitute them into this quadratic, we'll get a negative. In other words, when will our quadratic graph be below the x-axis? Because it's below the x-axis, well, that'll give us a negative answer. So if you choose values of x that are bigger than negative 4 and less than negative 2, they will give you negative answers. So for instance here, negative 3. If we do negative 3 squared, that's going to be 9. So negative 3 squared. Let's actually just do this here just to show you. Now, I wouldn't normally do this in an exam. I would just solve it. But I'm just going to show you why. Negative 3 squared, that's 9 plus 6 times negative 3. And then we're going to add 8. And let's just see what we get. Negative 3 squared, as I said, is 9 plus 6 times negative 3 would be negative 18. And then we've got our plus 8. 9 plus negative 18, well, 9 plus negative 18 means we're going to take away 18, so it'll be negative 9 plus 8 is equal to negative 1. So this point here would be negative 3, negative 1. So whenever we have a value of x of negative 3, that would give us a negative. So any value of x is bigger than negative 4 and less than negative 2 would work. If you tried negative 3.9, negative 3.5, negative 3, negative 2.9, negative 2.1, and so on, all those values would work. Negative 2 and negative 4 wouldn't work because we need to find when it's less than 0. So they would be when actually the quadratic is equal to 0. So let's just get rid of that for the minute. We didn't actually need that part. So we've been asked to find when this quadratic is less than 0. So when it's below the x-axis. So the values of x that are bigger than negative 4 and less than negative 2. So the values of x between negative 4 and negative 2. And that's it. So that's our answer. X would be bigger than negative 4 but less than negative 2. Okay, let's have a look at our next question, question number 2. So question number 2, we've been asked to solve the inequality x squared plus 2x minus 35 is bigger than 0. So again, let's sketch the quadratic of y equals x squared plus 2x minus 35. Okay, so to sketch this, let's just sketch our x and y axis, our x-axis and our y-axis. And again, let's label them x and y. So x and y. And to sketch this quadratic, we're going to find where it crosses the x-axis. So to find where a graph crosses the x-axis, we let y equal 0. So 0 equals x squared plus 2x minus 35. And then if we factorize this, we'll get 0 is equal to, and then in bracket, 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 bracket. And we want two numbers that times together to be negative 35 and add together to be 2. So I'm thinking plus 7 and minus 5. Because 7 times minus 5 is minus 35, and minus 5 plus 7 is 2. So that means our answers would be x equals negative 7 or x equals 5. So that means our quadratic will cross the x-axis at negative 7 and 5. So it's going to look something like this. Now this time we want to find when the quadratic is bigger than 0. In other words, when is the quadratic graph above the x-axis? So let's focus on this right hand side to begin with. Well, here if we had a value of x of 5, well 5 squared plus 2 times 5 take away 35 is 0, so that's why it's on the x-axis. But any value of x is bigger than 5, so 5.1 or 5.2 or 100 or a million and so on, whenever you substitute them into the quadratic, you're going to get a positive answer. So we know that x is bigger than 5 will give us one particular range of answers. Any value of x is bigger than 5 would work. But also there's another part of the graph that's above the x-axis. If we have any value of x that is less than -7, that would work as well. So -7.1, if you substitute that into this quadratic, that would work, or -8 or -9 and so on. We substitute them into this quadratic, you'd also get a positive answer. So that means that either x is less than -7 or x is bigger than 5. So they're the possible values of x that would work. And that's it. So there are our solutions. X is less than -7 or x is bigger than 5. The values in between -7 and 5 will give us a negative answer if we substitute them into this quadratic. And that's it. Okay, let's have a look at question number 3. Okay, so let's have a look at our next question, question number 3. So question number 3 says, solve the inequality x squared minus 9x plus 14 is less than or equal to 0. Okay, so first of all, let's sketch our axes. So we've got our x-axis and our y-axis. And we're going to sketch the graph of y equals x squared minus 9x plus 14. So to sketch this graph, so we want to find where it crosses the x-axis. So we want to find where it crosses the x-axis. So we're going to let y equal 0. So we've got 0 equals x squared minus 9x plus 14. And let's factor this hopefully, and we'll get 0 equals bracket, 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 and we've got x at the front of both brackets, and we want to find two numbers that multiply together to be 14 and add together to be -9, so it's going to be -7 and -2. And so that means to make each bracket 0, we'd have x equals 7, or we'd have x equals 2. So there are our values of x. So that means the quadratic graph will cross the x-axis at 2 and 7, so it's going to look something like this. So it's going to cross at 2 and 7. Now in this question we're asked to find when's the quadratic less than or equal to 0. So in other words, when's the height of this quadratic below or on the x-axis? Well, that's going to be any value of x that's bigger than or equal to 2 and less than or equal to 7. So x is going to be bigger than or equal to 2 but less than or equal to 7, because any value of x that is in between or equal to 2 and 7 would give us an answer that's negative or 0. So let's for instance try 3. If we were to do 3 squared, take away 9 times 3 plus 14, that's going to be negative. And obviously all those values that are bigger than or equal to 2 but less than or equal to 7 would work. So that's it, that's our solution. Okay, let's look at our next question. Okay, so question number 4. Question number 4, we've been asked to solve the inequality x squared minus 5x minus 24 is less than 0. Okay, so what we're going to do is we're going to sketch the quadratic y equals x squared minus 5x minus 24. So let's sketch that quadratic to begin with. So let's draw our x-axis and our y-axis, and let's label them x and y. So x and y, and we want to find where this quadratic crosses the x-axis, so let's let y equal 0. So 0 equals x squared minus 5x minus 24. And hopefully this will factorize, so 0 equals bracket, 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 and we're going to put x's in the front of both brackets, and we want to find two numbers that multiply together to be minus 24 and add together to be minus 5. And I'm thinking minus 8 and 3, because minus 8 times 3 is minus 24, and minus 8 plus 3 would be minus 5. So that means our values of x will be x equals 8 or x equals minus 3. So there are our values of x. That means the quadratic graph is going to cross the x-axis at minus 3 and 8. So minus 3 and 8. Now we want to find when this quadratic is less than 0. So in other words, when is this quadratic a negative? And there'll be the values of x that are bigger than minus 3 but less than 8. So x is going to be bigger than minus 3 and less than 8. Any value of x that's bigger than minus 3 but less than 8, when you substitute it into this quadratic, will give you a negative. And that's it. So that's it. That's our answer. Okay, let's look at question number 5. Okay, so question number 5 is solve the inequality x squared minus 121 is bigger than 0. Now this one looks slightly different than the other ones. It's still a quadratic, so let's sketch our quadratic of y equals x squared minus 121. So let's draw our x-axis and our y-axis. So we've got our axes, our x-axis and our y-axis. And let's sketch the quadratic. So we want to find where it crosses the x-axis. So we're going to let y equal 0. So 0 equals x squared minus 121. So let's solve this. So let's factorize it. And it can be factorized. It's the difference between two squareds. We've got x squared and 121, which is a square number, and a takeaway sign. So we're going to get 0 equals, and then bracket, 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 bracket. We're going to put x in the front of both brackets. And then one's going to have have minus 11 and one's going to have plus 11, because the square root of 121 is 11, and we do one with a plus sign and one with a minus sign. So that means that here x would be equal to 11, or here x would be equal to minus 11. So that means the quadratic graph will cross the x-axis at minus 11 and 11, so minus 11 and 11. Now in this question we've been asked to solve the inequality x squared minus 121 is bigger than 0. In other words, when is this quadratic graph above the x-axis? Well, if we have a look here, we've got this part. So this part here, whenever x is bigger than 11, any value of x that is bigger than 11, if you substitute it in here, you get a positive answer. So x is bigger than 11. So that's that part. Now let's have a look at this part here. Any value of x that is less than minus 11 would work as well. So for instance, minus 11.1, if you do minus 11.1 squared and then take away 121, that'll be positive as well. So it means that x is smaller than minus 11 or x is bigger than 11. There are solutions. The x is less than minus 11 or x is bigger than 11, and there are solutions. Okay, let's look at our next question, question number 6. Okay, our next question, question number 6, is solve the inequality x squared minus x minus 30 is bigger than or equal to 0. So again, let's sketch the quadratic of y equals x squared minus x minus 30. And then after we sketch that quadratic, we can find when it's bigger than or equal to 0. So let's sketch our axes, our x-axis and our y-axis, or our x-axis and then our y-axis. And then let's label them x and y, and we want to find where this quadratic crosses the x-axis, so we're going to let y equal 0. So 0 equals x squared minus x minus 30. Let's factorize this, so 0 equals, then bracket, 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 and put x's in the front of both brackets, and we want to find two numbers that multiply together to be minus 30, and we'll add together to be minus 1. So I'm thinking minus 6 and plus 5, because minus 6 times 5 is minus 30, and minus 6 plus 5 would be minus 1. So that means that x would be equal to 6, or x will be equal to minus 5. So that means that this quadratic graph will cross the x-axis at minus 5 and also at 6, so minus 5 and 6. Now we want to find this time where this quadratic graph is bigger than or equal to 0. In other words, which values of x, when you substitute them into this quadratic, you get either a 0 or a positive. So if we have a look here, we can see it's above the x-axis for any value of x that's bigger than 6, but it's also on the x-axis is equal to 0 whenever x is equal to 6. So it means that x can be bigger than or equal to 6, because any value of x that is either bigger than or equal to 6 would give us either a positive or 0. Now, in terms of this part of the quadratic here, any value of x that is less than minus 5 or equal to minus 5 would work as well. So x is less than or equal to minus 5 or bigger than or equal to 6. They're the possible values of x. Any value of x is either bigger than or equal to 6 or less than or equal to minus 5 would give us either a positive or 0. And that's it. Let's have a look at question number 7. So question number 7 says, solve the inequality x squared is bigger than 4 bracket 8 minus x close brackets. So this question is a little bit different than the ones we've looked at so far, because all the other ones we've looked at have been either bigger than 0, less than 0, bigger than or equal to 0, less than or equal to 0. But this time we've got the x squared and then we've got other expressions on the right hand side. So what we're going to do is we're going to bring everything to one side. So we're going to have, let's expand our brackets to begin with. So we'd have x squared is bigger than 4 times 8 would be 32, and then 4 times minus x would be minus 4x. So we've expanded our brackets. So we've now got that x squared is bigger than 32, subtract 4x. Now here what I'm going to do is I'm now going to take away 32 from both sides and add 4x to both sides to get 0 on the right hand side. So let's start off by adding 4x to both sides. So let's add 4x and add 4x. So on the left hand side of the inequality, we're going to have x squared plus 4x. And then on the right hand side, we've still got bigger than 32. We added 4x to get rid of this minus 4x. Now let's take away 32 from both sides. So take away 32 and take away 32. So the left hand side, we're going to have x squared plus 4x, subtract 32. And then we've got bigger than, and 32 take away 32 is 0. So we've now got an inequality that looks like questions 1 to 6. So now what we're going to do is we're going to sketch the graph of y equals x squared plus 4x minus 32. So we're going to sketch that quadratic. So let's draw our x-axis and our y-axis, our x-axis and our y-axis. Let's label them. So we've got our x and our y-axis. We want to sketch this quadratic, so we're going to let y equals x squared plus 4x minus 32. We want to find where it crosses the x-axis, so we're going to let y equal 0. So y equals 0. So 0 equals x squared plus 4x minus 32. And to solve this equation, we're now going to factorize. So we're going to get 0 equals, and then bracket, 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 bracket. We've got x and x. We want to find two numbers that multiply together to be minus 32 and add together to be 4. I'm thinking 8 and minus 4. So plus 8 and minus 4. Because 8 times minus 4 is minus 32. And minus 4 plus 8 is 4. So that means that either x is equal to minus 8 or x is equal to 4. So we've got our two values of x. That's where it crosses the x-axis. So the quadratic is going to cross the x-axis of minus 8 and 4. So minus 8 there and 4 there. So if we go back to our inequality, we've got x squared plus 4x minus 32 is bigger than 0. So in other words, we're looking to find when is this quadratic above the x-axis. So which values of x, when you substitute them into this quadratic on the left-hand side, do you get a positive? So any value of x is bigger than 4 would work. So x is bigger than 4. Or if we look at the left-hand side of the quadratic, any value of x that is less than minus 8. So x is smaller than minus 8. So either x is smaller than minus 8 or x is bigger than 4. Any of those values would work. Any value of x is bigger than 4 or less than minus 8 would work. So that's it. We've solved the inequality. X squared is bigger than 4 brackets 8 minus x, close brackets. And again, you could try these numbers. You could try, for instance, you could get negative 9 and substitute it into this inequality, and you should find it will work. Or for instance, you could choose a value of x that's bigger than 4, such as 4.1, and substitute it in, and you'll find that'll work as well. Okay, let's look at our next question, question number 8. Okay, so question number 8, this looks a bit more complicated. We've got solve the inequality 3x squared minus 5x minus 1 is smaller than 4x squared plus 7x plus 19. So here we've got obviously quadratics on both sides here. What we want to make is one side 0, and I'm actually going to make the left hand side of this inequality 0 because we've got 3x squared and 4x squared. So if we take away 3x squared from the left hand side and take away 3x squared from the right hand side, then that'll help us. So on the left hand side, if we take away the 3x squared, we're going to be left with minus 5x minus 1. And on the left hand side, we had 4x squared. We're taking away 3x squared, so that's 1x squared, or just x squared. And then we've got our plus 7x plus 19. So we've now got to this stage. We want to make the left hand side equal to 0. So let's add 5x's to both sides. So let's add 5x and add 5x. So on the left hand side, we'll just be left with minus 1, which is less than, and then we've got x squared. With 7x, we're adding 5x's. That's going to be plus 12x's, and then we've got plus 19. And then finally, we want the left-hand side to be 0, so let's add 1 and add 1. So the left-hand side will be now 0, and then we've got that smaller than x squared plus 12x, and then we had 19, we're adding 1, so that's then going to be plus 20. So we've now got this. I'm now actually just going to turn this around because I like having the quadratic on the left hand side. So if I turn this inequality around, I'd have x squared plus 12x plus 20. The inequality sign was this way. I'm turning it around, so it's now going to be is bigger than, and then 0. And then if we read this, we've got x squared plus 12x plus 20 is bigger than 0. And that's the same as this, where we've got 0 is less than x squared plus 12x plus 20. Okay, so we're now going to sketch the graph of y equals x squared plus 12x plus 20. So let's sketch our x and y axes, so our x-axis and our y-axis, and then get our pen and label them x-axis and y-axis. And we want to sketch this, so let's then let y equal 0. We want to find where it crosses the x-axis, so let's let y equal 0. So we're going to get 0 equals x squared plus 12x plus 20. And then let's factorize this right hand side. So if we factorize this right hand side, we're going to have x, and we want to find two numbers that multiply together to be 20 and add together to be 12. So I'm thinking plus 2 and plus 10, because 2 times 10 is 20 and 2 plus 10 is 12. Okay, so that means that either x is equal to negative 2 or x is equal to minus 10. And now if we sketch our quadratic, well, it would look something like this, where it crosses at minus 10 and minus 2. And we want to find, if we go back to our inequality, we want to find when x squared plus 12x plus 20 is bigger than 0. In other words, which values of x, when you substitute them into this quadratic, give you a positive answer. So that's going to be where the graph is above the x-axis. So if we have a look here, any value of x that is bigger than minus 2 will work. So x is going to be bigger than minus 2. For instance, minus 1 works, 0 works, and so on. Or any value of x that is less than minus 10 would work as well. They're also positive. So x is going to be less than minus 10. So that means that either x is bigger than minus 2 or x is less than minus 10. They're the values of x that would work. And that's it. We've solved this inequality. And again, you could check this. If, for instance, you got a value of x that's bigger than minus 2, such as minus 1.9, and you substitute it into this inequality, it would work. That's going to be quite messy, but it will work. And here, for instance, if you chose a value of x is less than minus 10, such as minus 400, and substitute them into this inequality, then that would work as well. Okay, let's look at question number 9. Okay, let's have a look at our next question, question number 9. So question number 9 says, solve the inequality 5x over x squared plus 4 is less than or equal to 1. So just like the other questions, what we want to do is we want to make either the left-hand side or the right-hand side equal to 0. So to begin with, let's multiply both sides by x squared plus 4. So let's multiply the left-hand side by x squared plus 4 and the right-hand side by x squared plus 4. So we're multiplying the left-hand side by x squared plus 4 to get rid of the divide by x squared plus 4. So we're just going to be left with our 5x. And then on the right-hand side of the inequality, so we've got our less than or equal to symbol, we had 1. We're multiplying it by x squared plus 4, so we'll get x squared plus 4. Just multiplying both sides by x squared plus 4. Now, as you can see here, we've got our x squared on the right-hand side here. So what I'm going to do is I'm now going to take away 5x from both sides. So to take away 5x from the left-hand side of the inequality and the right-hand side of the inequality. So 5x, take away 5x, so that's 0. It's going to be less than or equal to. And then we had x squared. We've now got our minus 5x. I'm just putting it there, so it's sort of in order of our quadratic. And then we've got our plus 4. Okay, so we've now got our inequality with a 0 there. So let's sketch the graph of y equals x squared minus 5x plus 4. And let's see what it looks like. So let's get our x and y axis, so our x-axis and our y-axis. And again, we want to find where this quadratic graph will cross the x-axis. So we'll let y equal 0. So we'll have 0 equals x squared minus 5x plus 4. So to solve this quadratic, we're going to factorize it, hopefully. So is it bracket, 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 and x. And we want to find two numbers that multiply together to be 4 and add together to be minus 5. So I'm thinking minus 1 and minus 4. Because minus 1 times minus 4 is 4, and minus 1 plus minus 4 will be minus 5. So that means that either x is equal to 1 or x is equal to 4. So there are two values of x. So let's sketch our quadratic. It crosses the x-axis at 1 and 4, so 1 and 4. Now let's go back to our inequality. Now actually I'm going to turn this around, so I'm going to write x squared minus 5x plus 4. Turning that inequality sign around will be bigger than or equal to 0, just turning that inequality around. So then we've got our quadratic is bigger than or equal to 0. So we want to find what values of x, when we substitute them into this quadratic, we get either a positive value or 0. So if we have a look at our graph, we want to find when it's either above or on the x-axis. So that will be any value of x that is bigger than or equal to 4. That would work. X is bigger than or equal to 4. Or here, in terms of the 1, any value of x is less than or equal to 1. So x is less than or equal to 1. So either x is less than or equal to 1 or x is bigger than or equal to 4. There are values of x. And again, you can substitute them into this and see if it works, and they will. Okay, let's look at question number 10. Okay, so this time we've been asked to solve the inequality 2x squared plus 9x plus 10 is bigger than 0. So this time, again, we've got our quadratic, and it's got 0 on the right-hand side, so that's quite nice. So let's sketch the graph of y equals 2x squared plus 9x plus 10. So let's sketch that. So let's get our x-axis and our y-axis. And let's label them x-axis and y-axis. I want to sketch this quadratic, so we want to find where it crosses the x-axis. So let's select y equals 0. So we've got 0 equals 2x squared plus 9x plus 10. And to find when this equals 0, let's hopefully factorize this. It's an uncalculated question, so hopefully we're not going to be using the quadratic formula or completing the square here. So 0 equals, and then bracket, 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 and let's go for 2x and x. Now we want to find two numbers that multiply together to be 10, and then whenever we expand our brackets we'll get our 9x. So I'm thinking if we put 2 over here and a 5 here, let's just check that. Let's see if that works. 2x times x would be 2x squared, and then 2x times 2 is equal to 4x, and 5 times x is 5x, and 4x plus 5x is 9x, and then 5 times 2 is equal to 10. So yeah, that works. So let's get our solutions here. So here, either x is equal to minus 2, and in terms of this bracket, I like to put them equal to 0. 2x plus 5 is equal to 0. Take away 5 and take away 5. We're going to get that 2x is equal to minus 5, and then dividing by 2, x is equal to minus 5 over 2, or minus 2.5. So that means that this quadratic will cross the x-axis at minus 2.5 and minus 2. So it's going to look something like this. So it's going to cross at minus 5 over 2, or minus 2.5, and minus 2. Now if we go back to our inequality, we want to find when this quadratic graph, what values of x, when we substitute them into this quadratic, do we get a value that's bigger than 0? In other words, a positive. So that's when is this quadratic graph above the x-axis. So here, in terms of this value of x, so here, any value of x that is bigger than minus 2 will work. So x is bigger than minus 2 would work. Or, and in terms of this case, anything that is less than minus 5 over 2 would work. So x is less than minus 5 over 2. So any value of x is bigger than minus 2 or smaller than minus 2.5 would work here. And you can test it. You can substitute into this inequality and you'll find that that works. And that's it. Okay, let's look at our next question, question number 11. Okay, so question number 11, we've been asked to solve the inequality 9x squared minus 16 is less than or equal to 0. Okay, so here we've got a quadratic, and it's the difference between two squared, so it's going to factorize quite nicely. But here we've got a quadratic, and it's less than or equal to 0, so let's sketch it. Y equals 9x squared minus 16. So let's do our x-axis and our y-axis. Let's draw those, and let's label them our x-axis and our y-axis. And we want to sketch this quadratic, so let's let y equals 0 to find what crosses the x-axis. So 0 equals 9x squared minus 16. And then this factorizes. It's the difference between two squareds. So let's square root each of these. So 9x squared, if we square root that, we're going to get 3x and 3x. and 16. If we square root that, we get 4 and 4. And we're going to do one with a plus sign and one with a minus sign. Okay, now let's get our solutions. So here, either this bracket is equal to 0 or this bracket is equal to 0. So let's start off with this bracket. 3x plus 4 equals 0. Take away 4 from both sides will give us 3x is equal to minus 4. And then divide both sides by 3 would give us x is equal to minus 4 thirds. So that's one particular value of x. Now let's look at this bracket. We'd have 3x minus 4 is equal to 0. Add 4 to both sides. So we're going to get that 3x is equal to 4. And divide by 3, we're going to get that x is equal to 4 thirds. So that means that this quadratic graph will cross the x-axis at minus 4 thirds and 4 thirds. So it's going to look something like this. Minus 4 thirds and 4 thirds. Now let's look at our inequality. We want to find the values of x, so whenever we substitute them into this quadratic, we get a value that is less than or equal to 0. So in other words, it's equal to 0 or negative. So that means that it's going to be any value of x that is bigger than or equal to minus 4 thirds, but less than 4 thirds. So it's any value of x that's between these values, but also equal to those values, because x can be bigger than or equal to minus 4 thirds and less than or equal to 4 thirds, like so. So any value of x in between those values would give you a negative, and any value of x that is equal to those values would give you 0, so that would be less than or equal to 0. And that's it, that's our solution. Okay, let's look at our next question, question number 12. Okay, let's have a look at our next question, question number 12. So question number 12 says, solve the inequality x squared is bigger than 25 but less than 64. So what I'm going to do is I'm going to treat this as two separate inequalities. I'm going to look at the inequality that 25 is less than x squared, or if we turn that around, x squared is bigger than 25. And I'm also going to have a look at this inequality that x squared is less than 64. And I'm going to then have a look at those and find our solutions for those, and then find out which values of x would satisfy both of them. Okay, so let's start off with this one here. X squared is bigger than 25. I'm now going to take away 25 from both sides to get that x squared minus 25 is bigger than 0. And then I'm going to sketch the graph of y equals x squared minus 25. And we're going to find when that is bigger than 0. So let's do that. So let's sketch that. So let's draw our x-axis and our y-axis. And then let's draw the graph of y equals x squared minus 25. So we want to find where it crosses the x-axis, so we're going to let y equal 0. So we're going to get that 0 equals x squared minus 25. And this factorizes, we're going to get the 0 equals bracket, 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 bracket. It's the difference between two squared, so we've got an x and an x, a 5 and a 5, one with a plus sign and one with a minus sign. So that means our two solutions will be x equals negative 5 or x equals 5. So that means that this quadratic will cross the x-axis at negative 5 and 5. So it's going to look something like this. Now we want to find when this quadratic is bigger than 0. So which values of x, when we substitute them into this quadratic, do we get a positive? So that's going to be when this quadratic graph is above the x-axis. So that was 5 and that's a negative 5. So that means that any value of x is bigger than 5 would work. So x is bigger than 5. Or here, any value of x is less than minus 5 would work as well. So they're the values of x that would satisfy this inequality. Values of x that are bigger than 5 or less than minus 5. Okay, now let's have a look at this inequality. We've got x squared is less than 64. So again, let's take away 64 from both sides. We're going to get the x squared minus 64 is less than 0. And then let's sketch the quadratic y equals x squared minus 64. So let's draw our x and y axis. So our x-axis and our y-axis. And let's label them x and y. And then we want to find where it crosses the x-axis, so we're going to let y equal 0, so we're going to get to 0 equals x squared minus 64. And then to solve this, let's factorize the right hand side, and it's the difference between two squares again, so 0 equals bracket, 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 x and x, 8 and 8, and then a plus sign and a minus sign. So that means that either here x is equal to minus 8, or here x is equal to 8. So that means it crosses the x-axis at minus 8 and 8. It looks something like that, minus 8 and 8. And the question this inequality said to find when x squared minus 64 is less than 0. So which values of x, when we substitute them into this quadratic, do we get that it's a negative below the x-axis? So it'll be any value of x that is bigger than minus 8 or less than 8. Any value of x in between minus 8 and 8 would work. So we've looked at the x squared is bigger than 25, and we found that any value of x that is bigger than 5 or less than minus 5 would work for that inequality. And for this inequality, x squared is less than 64, and any value of x between negative 8 and 8 would work for that inequality. Okay, so we need to find values of x that would satisfy both of these inequalities. So I'm going to draw a number line and I'm going to draw the inequalities on the number line, and I'm going to find where they overlap, and where they overlap will be the values of x that would work. So let's do that. Okay, so I've just drawn a little sketch of a number line going from negative negative 10 to 10. And let's represent both of these inequalities on this number line. So let's start off with this inequality here. X is less than negative 5 or X is bigger than 5. So less than negative 5, let's do a hollow circle and negative 5 and an arrow to the left. So that region would work. Or X is bigger than 5, so a hollow circle at 5 and an arrow to the right. So that's that first inequality represented in this number line. Now here we've got other possible solutions of X for this inequality. So we've got that X is between negative 8 and 8. So X is bigger than negative 8 but less than 8. So that means it's in between negative 8 and 8. And it can't be negative 8 or 8, so it's hollow circles at both and then join them up. So put our solutions to x squared is bigger than 25 on the number line, and our solutions to x squared is less than 64 in the number line. And to satisfy both of those, then it's going to be when they overlap. So if we have a look here, a value of 0 wouldn't work because it wouldn't work for the top inequality. It would work for the other one, but not this one. For instance, here we couldn't have a value of negative 9 because negative 9 would only work for this inequality, but not this part. But where they overlap, so let's have a look at this part here and this part here. So looking at this part here, any value of x that is bigger than negative 8 but less than negative 5 would work. So x is bigger than negative 8 but less than negative 5. That would work for this part here. And then in terms of this part here where they overlap, any value of x that is bigger than 5 but less than 8 would work as well. So or x is bigger than 5 but less than 8. So any value of x that is in between negative 8 and negative 5, or 5 and 8 would work. So let's go up here. If we had 6, so for instance, if x was equal to 6, you'd have 6 squared. 6 squared is equal to 36, and it's in between 25 and 64. You could try, for instance, here if we have a look at this inequality, negative 7. Negative 7 squared is 49, and that would work as well. So that's it. So there are solutions. Okay, let's look at our next question, question number 13. Okay, let's have a look at our next question, question number 13. So question number 13 says, solve the inequality 7x squared minus 22x plus 16 is less than or equal to 0. Okay, so this is actually quite nice because we've got a 0 here. So let's sketch the graph of y equals 7x squared minus 22x plus 16. So to sketch this quadratic graph, what we're going to do is let's draw our x and y axis, so our x-axis and our y-axis, and let's label them x and y, so x and y. And we want to find where this quadratic graph will cross the x-axis, so we're going to let y equal 0. So 0 equals 7x squared minus 22x plus 16. Okay, so we now want to solve this, so let's try to factorize it to begin with. So 0 equals bracket, 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 and let's go for 7x in one bracket and x in another bracket. And we want to find two numbers that multiply together to be 16, and that whenever we expand our brackets, we're going to get minus 22. Okay, so because they tend together to be positive, they're both going to have to be negative here, because when we expand it to get negative 22, they both can't be pluses. So they're both minus and minus. And we want to find two numbers that tend together to be 16, and when we expand our brackets, we get 22. Okay, so I'm thinking if we put a minus 2 in here and a minus 8 there, that would work. Let's just check. 7x times x is 7x squared. Fantastic. 7x times minus 2 would be minus 14x. Minus another 8x would be minus 22x. And minus 8 times minus 2 is 16. Fantastic. So here, that means that x is equal to 2. Or here, we'd have 7x minus 8 is equal to 0. Add 8 to both sides, so we have 7x equals 8. And divide by 7, we'd have x is equal to 8 sevenths. So either x is equal to 8 sevenths or x is equal to 2. So that's where this quadratic will cross the x-axis, 8 sevenths and 2. So it's going to look something like this. So it crosses 8 sevenths and 2. So 8 sevenths is there and 2 would be there. Now, if we have a look here, we want to find when this inequality is less than or equal to 0. So in other words, which values of x, when we substitute them into this quadratic, we get a negative or 0. So that means that any value of x that is in between 8 sevenths and 2 would give you a negative answer. And if it's equal to 8 sevenths or 2, it would give you it's equal to 0. So that would work as well. So that means that x is going to be bigger than or equal to 8 sevenths, but less than or equal to 2. And that's it. They're the possible values of x that would satisfy that inequality. Okay, let's look at our next question, question number 14. Okay, so question number 14 says, find the set of values of x for which x squared minus 2x minus 24 is less than 0, and 12 minus 5x is bigger than or equal to x plus 9. So what we're going to do here is we're going to solve both of these inequalities, this quadratic inequality and this linear inequality. We're going to solve both of those, and then we're going to draw a number line and find then the values of x that would satisfy both of them. Okay, so let's start off with our quadratic. So with our quadratic to begin with, we've got a 0 on the right hand side, so that's quite nice. So let's draw the graph of y equals x squared minus 2x minus 24. So let's sketch that graph to begin with. So let's draw our x-axis and our y-axis, or our x-axis and our y-axis, and let's label them x and y. And to sketch this quadratic, what we're going to do is let's find where it crosses the x-axis. So let y equal 0. So we'd have 0 is equal to x squared minus 2x minus 24. And then if we factorize this, 0 equals bracket, 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 x and x. And we've got two numbers that multiply together to be minus 24 and add together to be minus 2. So it's going to be minus 6 and 4. So minus 6 times 4 is minus 24. And minus 6 plus 4 will be minus 2. So that means that the graph will cross the x-axis at 6 and minus 4. So the graph will cross the x-axis at minus 4 and 6 like so. And we want to find when the quadratic is less than 0. So in other words, which values of x, when we substitute them into this quadratic, we get a negative. So that's going to be any value of x that is bigger than minus 4 but less than 6. So it means that x is bigger than minus 4 but less than 6. So they're the values of x that would work for that inequality, but they also have to satisfy this inequality as well. So let's change colour of pen here to blue, and let's solve this inequality. So if I wanted to solve this inequality, the first thing I would do is I'd look at this minus 5x, and I'd think, well, let's add 5x to both sides to begin with. So if I add 5x to both sides, on the left-hand side, we'll just be left with 12. And on the right-hand side, we'd have that is going to be, we've got our bigger than or equal to sign. X plus 5x would be 6x, and we've still got our plus 9. Fantastic. I'm just going to turn this around. So I'm going to write our 6x plus 9 and then turn the inequality sign around as well. And then we've got 12. So 6x plus 9 is less than or equal to 12. And that's what this says if we read it this way. Okay, so if we want to solve this, then let's take away 9 and take away 9. So we've got 6x is less than or equal to 3. And then if we divide by 6, we're going to have that x is less than or equal to a half, because 3 divided by 6 is a half, or 0.5. Okay, so we've got here for this inequality, this one, x has to be bigger than minus 4 and less than 6. But for this inequality, x has got to be less than or equal to 0.5. So let's draw this on a number line. So a little sketch of a number line. Okay, so I've just drawn a quick sketch of a number line, and let's represent this solution on the number line. So x is bigger than minus 4, but less than 6. So negative 4, a hollow circle, 6, a hollow circle, and any value of x is in between those. So any value of x that is bigger than minus 4, but less than 6 would work. Now our other inequality, so this one here, we've got that x is less than or equal to 0.5. So 0.5 would be a half. It's in the middle here. And it's less than or equal to it. So I'm going to do a shaded in circle because it can be equal to half. And it's less than that. So an arrow to the left like so. And we want to find where they overlap because that would satisfy both of these inequalities. So as you can see here, for instance, if we had negative 2 would work for both of them. Negative 1 would work for both of them. 0 would work for both of them. Actually, I'm just going to write 0.5 there just to show what that value is there, where the shaded in circle is, so 0.5. So if we have a look at where it overlaps, that's going to be any value of x that is bigger than minus 4, so it's going to be bigger than minus 4, but less than or equal to 0.5. So that's our solution. The x is going to be bigger than negative 4, but less than or equal to 0.5. And that's it. That's the region that overlaps there. And that's it. Okay, so let's have a look at our next question, question number 15. So question number 15 says, find the set of values of x for which x squared minus 100 is bigger than 0, and x squared plus 8x minus 105 is bigger than 0. So let's solve each of these quadratic inequalities. So let's start off with the left-hand one. So x squared minus 100 is bigger than 0. So let's sketch the graph of y equals x squared minus 100. If we sketch that graph, we'll then be able to find when it's bigger than 0. So we've got the x-axis and the y-axis. So we want to find where this quadratic crosses the x-axis. So let's let y equal 0. So we'd have 0 equals x squared minus 100. And then let's factorize this. So 0 equals bracket, 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 bracket. And it's difference between two squared. So we'll have an x at the front of both brackets, a minus and a plus, and then 10 and 10. So that means that either x is equal to 10 or x is equal to negative 10. So our quadratic would look something like this. And it'll cross the x-axis at negative 10 and 10. And we want to find where this quadratic is bigger than 0. So we want to find the values of x where x squared minus 100 is bigger than 0. So if we have a look at the graph, that's where it's going to be above the x-axis. So that's going to be any value of x that is bigger than 10. So x is bigger than 10. Or let's look to the left-hand side of the graph. So here, any value of x that is less than minus 10 would also work. So x is less than minus 10. So there are possible values of x. So any value of x is bigger than 10 or less than negative 10 would work for this quadratic. Okay, let's look at the other quadratic. So we've got x squared plus 8x minus 105 is bigger than 0. So let's let y equal x squared plus 8x minus 105. And let's sketch our quadratic and find where it's bigger than 0, so where it's above the x-axis. So let's sketch the quadratic. So here's the x-axis and here's the y-axis. And let's label them x and y. And we want to find where this quadratic crosses the x-axis. So let's let y equal 0. So 0 equals x squared plus 8x minus 105. And then if we solve this, 0 equals, then bracket, x and x. We want to find two numbers that multiply together to be 105 and add together to be 8. So because it's negative 105, one's going to be a plus and one's going to be a minus. And I'm thinking 15 and minus 7, because 15 times minus 7 would be minus 105, and minus 7 plus 15 would be 8. So that would work. So that means our solutions are x equals negative 15 or x equals 7. So we now know where the quadratic crosses the x-axis. It crosses the x-axis at minus 15 and 7. So it looks something like this, minus 15 and 7. So minus 15 there and 7 there. Now we want to find the values of x, so whenever we work out x squared plus 8x minus 105, we're going to get a positive. In other words, when's this quadratic graph above the x-axis? And that'll be any value of x that's bigger than 7, so x is bigger than 7. Or, if we have a look at the left-hand side of the quadratic, any value of x that is less than minus 15. So x is smaller than minus 15. So that's fantastic. We've now solved both of the quadratic inequalities. Now we want to find the set of values that satisfy both of them. So let's sketch both of them on a number line. So let's draw a little number line. So here we've got a little number line. I've just done a line with 0 in the middle. I'll put some of the other numbers on this number line in a second. And if we look at our solution to the first quadratic inequality, we had that x is less than negative 10. So let's let here be negative 10. So negative 10 would be there. And a hollow circle, and less than negative 10 would look something like that. Or we've got the x is bigger than 10. So then 10 would be there, and another hollow circle there, and then an arrow to the right. So this represents solutions for the first quadratic inequality. So any value of x that is less than negative 10 or bigger than 10 would work for that quadratic inequality. Okay, now let's look at our next quadratic inequality and our solution to that. We had that x was less than negative 15, so negative 15, that would be roughly there somewhere, so negative 15, and less than negative 15, so a hollow circle and an arrow to the left. Or x is bigger than 7, so let's put 7 there, and then a hollow circle there, and then an arrow to the right. Now we want to find values of x that satisfy both of these quadratic inequalities. So we need to satisfy both of them. So that means we want to find where they overlap with each other. So here, if we look at the left-hand side, well, negative 11 wouldn't work because it would only work for the first quadratic inequality, but not the second one. So here, where they overlap would be any value of x that is less than negative 15. So that's one part of our solution, that x is less than negative 15. So any value of x that is less than negative 15 would satisfy both of the inequalities. And then if we have a look at these solutions, we want to find where they overlap. So that'll be any value of x is bigger than 10. So x is bigger than 10. So that's our solutions. That any value of x that is less than negative 15 or any value of x that's bigger than 10 would satisfy both of those quadratic inequalities. So for instance, if we had x was equal to 11, x was equal to 11 would work for both of those quadratic inequalities. Or if we had, for instance, a value of x such as negative 16, if we substituted in negative 16 into those quadratic inequalities, it would work for both of them as well. And that's it. So there's our solutions. The set of values of x that would satisfy both of those quadratic inequalities would be x is less than negative 15 or x is bigger than 10. And that's it. Okay, let's look at our next question. Okay, so question number 16. So question number 16 says the width of a rectangular field is x meters, and the length of the field is 30 meters longer than the width, and the perimeter of the field is less than 500 meters, and the area of the field is greater than 4,000 meters squared, or 4,000 square meters. And by writing suitable inequalities, find the possible values of x. So I'm going to start off by drawing a sketch of this information. So we've got a rectangular field, so let's draw a rectangle. And we're told the width of the field is x meters, so let's call the width of it x meters, and the length of it is 30 meters longer than the width. So if this is x meters, this would be x plus 30 meters because it's 30 meters longer. And the perimeter of this field is less than 500 meters. So we can find an expression for the perimeter, and it's less than 500 meters, so we could create an inequality there. And we're also told the area of the field is greater than 4,000 meters squared, or 4,000 square meters, so we can then form another inequality. And it says by writing suitable inequalities, find the possible values of x. Okay, so let's start off with the perimeter. So let's deal with the perimeter to begin with. So in terms of the perimeter, we're told the perimeter of the field is less than 500 meters. So if this side is x, this side is x, and if the top is x plus 30, the bottom is x plus 30. Okay, so let's find the perimeter of this field. So to find the perimeter of the field, we're going to add up all the lengths around the outside of this rectangle. So we're going to add up the length, the width, the length, and the width for x plus 30, x plus 30, and x. So x plus 30 plus x plus x plus 30 plus x, well, that would be 4x. And then we've got 30 plus 30, that would be plus 60. So that's the perimeter of the field, 4x plus 60, but we're told it's less than 500 meters, so that's less than 500 meters. So that's an inequality. We've got 4x plus 60 is less than 500. Now we can actually solve this. We could solve this by taking away 60 from both sides. So taking away 60 from the left-hand side and taking away 60 from the right-hand side. So on the left-hand side, we would have 4x plus 60. Take away 60 would just be 4x. And then on the right-hand side, we'd have that's less than 500. Take away 60 would be 440. And then if we divide by 4 and divide by 4, we'd have the x is less than 110. So that means that the width of the rectangle is less than 110 meters. Now let's deal with the area. The area of the field, so let's write area. The area of the field is greater than 4,000 square meters. So let's find the area for this rectangle. So the area of this rectangle will be the length multiplied by the width. So that'd be the width, which is x, multiplied by the length, which is x plus 30. So this would be the area of the rectangle, and we're told that that is bigger than 4,000 meters squared, or 4,000 square meters. That's bigger than 4,000. Okay, so now let's expand our brackets. X times x is x squared. And then we've got x times 30, that'd be plus 30x. And that is bigger than 4,000, so bigger than 4,000. So now we've got this quadratic inequality. So let's solve this to find the possible values of x which should work for the area. And then when we do that, we solve that, we'll then have the possible values of x for the perimeter, that would work for the perimeter, for the information we're given for the perimeter. And we'd have the possible values of x that would work for the area. And then we'd figure out which ones would work for both of them. Okay, so let's solve this. So if we want to solve this quadratic inequality, let's take away 4,000 from both sides, because we want this right-hand side to be 0. So we'd have x squared plus 30x minus 4,000 is bigger than 0, just taking away 4,000 from both sides of this inequality. Okay, now we want to solve this quadratic inequality, so let's sketch the graph of y equals x squared plus 30x minus 4,000. And whenever we sketch this graph, that'll then help us solve this quadratic inequality. So let's sketch the x-axis and the y-axis, so the x-axis and the y-axis, like so. And let's label it x-axis and y-axis. And then if we want to find where this quadratic crosses the x-axis, we want to let y equal 0. So we'd have 0 equals x squared plus 30x minus 4,000. And then if we factorize this, we'd get bracket, 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 x and x. And we want to find two numbers that multiply together to give us minus 4,000 and add together to be 30. So I'm thinking 80 and minus 50, because 80 times minus 50 would be minus 4,000, and minus 50 plus 80 is 30. And then if we solve this, we'd have that x is equal to minus 80, or x is equal to 50. So that means we can now sketch our quadratic, where it's going to cross the x-axis at minus 80 and 50. So minus 80 and 50, like so. So that's minus 80 and 50. Okay, so we've now sketched our quadratic. Let's go back to our quadratic inequality. We want to find when the quadratic, the x squared plus 30x minus 4,000, so this quadratic, is bigger than 0. So in other words, when's it above the x-axis? Okay, so let's find those values of x. So any value of x that's bigger than 50 would work. So x, and I'm just going to go down here. So x is going to be bigger than 50, because any value of x bigger than 50 would work. Or in terms of the left-hand side of this quadratic, and I'll come back to that in a second, any value of x that is less than minus 80 would work as well. So x is less than minus 80, or x is bigger than 50. So they're the possible values of x which would satisfy this quadratic inequality. But given the context of the question and the fact that x is the width of the rectangle, well, we can actually ignore these solutions here, because x is less than negative 80 wouldn't make sense in terms of this rectangle. Okay, now in terms of the area of the rectangle, for this rectangle to have an area that's bigger than 4,000 meters squared, or 4,000 square meters, we need the width of the rectangle to be bigger than 50 meters. So x has to be bigger than 50 meters. But also for the perimeter to be less than 500 meters, we've found that we need the width of the rectangle to be less than 110 meters. So that actually means that this value of x, the value of x has to be, so that means the value of x has to be bigger than 50 meters, but less than 110 meters. So the value of x has to be bigger than 50, but less than 110 meters. And then any value of x that's bigger than 50, but less than 110 meters, would mean that this rectangle would have a perimeter that's less than 500 meters, but an area greater than 4,000 meters squared. And that's it. So that's our solution. The possible values of x are x is bigger than 50, but less than 110. And that's it. Okay, so let's have a look at our next question, question number 17. So question number 17 says the area of this rectangle is greater than 40 centimeters squared, and we've got the length of it being 2x minus 1 centimeters and the width of it being x plus 3 centimeters. And we've been asked to work out the range of possible values of x. Okay, so we're told the area of this rectangle is greater than 40 centimeters squared. So let's find the area of this rectangle. And to find the area of the rectangle, we're going to do the length multiplied by the width. So 2x minus 1 multiplied by x plus 3 is the length times the width. So that's the area of the rectangle. And that's greater than 40 centimeters squared. So that's going to be greater than 40. Okay, now let's expand our brackets. 2x times x would be 2x squared. 2x times 3 would be plus 6x. Minus 1 times x would be minus x, and minus 1 times 3 would be minus 3. And that is greater than 40. So let's simplify this. So on the left-hand side, we've got 2x squared. And then we've got 6x, take away x, that's going to be plus 5x. And then we've got subtract 3 is greater than 40. So whenever we're dealing with quadratic inequalities, it would be great if one of the sides is 0. So let's take away 40 from both sides. So let's take away 40 from the left-hand side, and let's take away 40 from the right-hand side. So the left-hand side will now become 2x squared plus 5x minus 43 is greater than 0. Okay, so we now want to solve this quadratic inequality. So what we're now going to do is we're going to sketch the graph of y equals 2x squared plus 5x minus 43. And we'll then draw our x-axis and y-axis. So we've got our x-axis and our y-axis. And let's label them x and y. And we want to find where this quadratic crosses the x-axis, so we're going to let y equal 0. So 0 equals 2x squared plus 5x minus 43. Now this question is a calculator question, just checking, yeah, because we're going to be using the quadratic formula here to solve this quadratic. So let's let a equal 2, b equal 5, and c equal minus 43. So we want to solve this quadratic to find where the graph crosses the x-axis. So we're going to use the quadratic formula, and the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we've got x equals negative b, so it's going to be negative 5, plus or minus the square root of b squared, so it's going to be 5 squared, which is 25, minus, and then I like to put this in a bracket, 4 times a times c, so it's going to be 4 times 2 times minus 43, close brackets, and then just carry that on. And that's all divided by 2a, and a is equal to 2, so 2a would be 4. Okay, now let's work this out. So we then have, I'm just going to go over this side. So we've got x equals negative 5 plus or minus the square root of. And then we've got 25 minus. And now let's work out what goes inside the bracket. So 4 times 2 times minus 43 is equal to minus, so let's keep that in brackets, minus 344, close brackets, all divided by 4. So that means that x equals negative 5 plus or minus the square root of. We've got 25 minus minus, so it's going to be 25 plus 344, which is 369, all divided by 4. So that means that x equals negative 5 plus the square root of 369 divided by 4, or x equals negative 5 minus the square root of 369 divided by 4. And let's work these out. So whenever we work these out, we get minus 5 plus the square root of 369 divided by 4. And that means that x equals 3.552343 and so on. Or x equals, and then if we just change the plus to minus on the numerator in the middle, we get that's equal to minus 6.0523 and so on. So let's sketch this quadratic. It crosses the x-axis at negative 6 point so on, and it crosses it at 3.55 and so on. So it's going to be minus 6.05 and so on, and 3.55 and so on. So we've sketched the quadratic and we know where it crosses the x-axis. If we go back up to the quadratic, we want to find where it's bigger than 0. So that means, and if we go to this quadratic, we want to find where it's bigger than 0. I'm just going to change color of ink here because I've kind of set this out in not the best of ways. So I'm actually going to go over here for my solutions. I should have really set this out a bit better. So we want to find where the quadratic is bigger than 0. So the values of x that whenever we substitute them into the quadratic, we get a positive. So where the quadratic is above the x-axis. So that means that for the right-hand side, x is going to be bigger than 3.55 and so on, or the left-hand side of the quadratic where x is less than negative 6.05 and so on. Now in terms of our solutions here, we want to find the possible values of x, but if we have a look at this, whenever we've got x is equal to a value that's less than negative 6.05 and so on, well, if we do minus 6.05 and so on plus 3, that's negative, and that wouldn't work for the width of this rectangle, so we can't have that. So that means that the only values of x that would work in this situation would be the values of x that are bigger than 3.55 and so on. So let's write that down. The x would be bigger than 3.552 and so on, and that's it. Okay, let's look at our next question, question number 18. So question number 18 says, find the set of values of x for which x squared minus 9 is less than 0 and 3x squared minus 19x plus 20 is less than 0 as well. Okay, so let's solve each of these inequalities. So let's start off with the left-hand one. So I'm going to start off by sketching the quadratic. So we've got y equals x squared minus 9, and we want to find where this quadratic crosses the x-axis, so let's let y equal 0, so we'd have 0 equals x squared minus 9, and we'd solve this by using the difference between two squared, so we'd have bracket, 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 x and x, 3 and 3, one with a plus sign and one with a minus. So then that means that this bracket, x would be equal to 3, and this one, x would be, or x is equal to negative 3. So that means that this quadratic crosses the x-axis at minus 3 and 3. So it looks something like this, minus 3 and 3. And we want to find where x squared minus 9 is less than 0. So that's where this quadratic graph is below the x-axis. So that means that x is going to be bigger than minus 3, but less than 3. So that means that x is between negative 3 and 3. So it's any value of x between those two values. Okay, so we've solved that quadratic. Now let's look at this one. So let's sketch the graph of y equals 3x squared minus 19x plus 20. So we're going to sketch this quadratic. Let's draw our x and y axis. So our x-axis and our y-axis would look something like that. And let's label them x and y. And we want to find where this quadratic crosses the x-axis, so let's let y equal 0. So we'd have 0 equals 3x squared minus 19x plus 20. And then we're going to factorize this, so that would be bracket, 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 bracket. Hopefully we're not having to use the quadratic formula again. 3x and x. And we want two numbers that multiply together to be 20. And when we expand our brackets, we get our minus 19x. So I'm thinking, well, they're both going to have to be negative, so negative and negative. And I'm thinking 5 and 4, so let's put a 5 there and a 4 there. And yep, that would work. 3x times x is 3x squared. 3x times minus 5 would be minus 15x, and minus another 4x would be minus 19x. That's fantastic. And then our plus 20. Okay, so we want to find where this equals 0. So that means that either x is equal to 5 for this bracket, or here we've got 3x minus 4 equals 0. Add 4 to both sides, so 3x equals 4, and divide by 3, x is equal to 4/3. That means that x is equal to 4/3, or x is equal to 5. So it's going to cross the x-axis at 4/3 and 5. So 4/3 there and 5 there. And we want to find where this quadratic is. This quadratic is less than 0. So that's where the quadratic graph is below the x-axis. So that'll be the values of x that are less than 5. That's a 5 there. It's an awful 5. 5. So that's where x is less than 5, but bigger than 4/3. So x is going to be bigger than 4/3, but less than 5, or between 4/3 and 5. Any value of x between those values would work. So this is fantastic. We now know for this quadratic, x is going to be between negative 3 and 3. And for this quadratic, x is going to be between 4/3 and 5. So let's sketch those on a number line. Okay, so here's a number line, and let's look at our first one. X is between negative 3 and 3. So here we've got negative 3, here we've got 3, and it's going to be between those values, so it's going to be hollow circles, and we're going to join them up. Any value of x between those values would satisfy that inequality. Okay, now let's look at the next one. X is between 4/3 and 5. So 4/3, that's 1.333 and so on. So 4/3 would be here somewhere, 4/3 there, and 5, that'd be there, and it'd be hollow circles there and there. And let's join them up. So we now want to find the values of x which would satisfy both of these inequalities. So that's where they overlap, and they overlap for any value of x is bigger than 4/3 but less than 3. So that means that x is going to be less than 3 but bigger than 4/3. And that's our answer. X is going to be bigger than 4/3 but less than 3. So let's write that down. And that's it. Okay, let's look at our last question, question number 19. So question number 19, we've got this triangle, and we've got the base of the triangle and the perpendicular height of the triangle. And part A says, write an expression for the area of the triangle. So the area of a triangle, the area of a triangle, area is equal to half the base times the perpendicular height, or half the base times the height. So for this triangle, it's going to be half the base, so half, and then in brackets, the base, x plus 2, times the height, which is 2x minus 5. That's the perpendicular height. And that's it. That's our expression for the area of the triangle. Actually, I'm going to expand the brackets because perhaps if we expand these brackets, we might be able to divide all the terms by 2 or half them all. Maybe. Let's have a look and see. So we'd have a half and then in brackets, and let's expand here. X times 2x would be 2x squared. Then we've got x times minus 5. That's going to be minus 5x. We've then got 2 times 2x. That's going to be plus 4x. And finally, 2 times minus 5 would be minus 10. So we've expanded our brackets. Now let's simplify. So we'd have a half and then in brackets 2x squared. Minus 5x plus 4x would be minus x. And then we've got our minus 10. So we can't actually divide all of those terms by 2. But if we had perhaps here minus 6x, we'd be able to half all these terms. But I'm just going to leave the answer as a half and then in brackets 2x squared minus x minus 10. And that's it. So that's the area of the triangle using half the base times the height. Okay, part B. Part B says the area of the triangle is greater than 80.5. So this area is going to be greater than 80.5. And we've been asked to show this. So the area of the triangle, a half of 2x squared minus x minus 10, the area of the triangle is going to be greater than 80.5. Okay, so we've now got this. We want to get it to look like this because we've been asked to show that 2x squared minus x minus 171 is bigger than 0. So we've got bigger than, that's good. So now what I'm going to do is I'm going to multiply both sides of this inequality by 2. So if I multiply the left-hand side by 2, I get rid of the half. So that's going to leave us with 2x squared minus x minus 10. And if I multiply the right-hand side of the inequality by 2, if I double this, I get 161. Okay, now if we have a look at what we're trying to get and what we've got, well, if we just take away 161 from both sides, we're going to get 2x squared minus x and then minus 171 is bigger than 0. And that's it. We've shown that. And that's it. Okay, let's look at our next part, part C. So part C says find the possible ranges of values of x. So let's solve our quadratic inequality. So we've got this quadratic inequality. Let's sketch y equals 2x squared minus x minus 171 and see what we get. So let's draw our x-axis and our y-axis. And we've got our x-axis and our y-axis. And we want to sketch this quadratic, so let's find where it crosses the x-axis. So let y equal 0. So we'd have 0 equals 2x squared minus x minus 171. Okay, so now we want to try and factorize this if we can. It's a calculator question, so you could, if you want to, use the quadratic formula for this. I'm going to factorize it because I know it factorizes, but if you couldn't see that it factorizes, you could use completeness square, which would be a bit messy for this. You could use the quadratic formula, or you could see if it factorizes, and it does. So we've got here, we're going to have 2x and x. And we want to find two numbers that multiply together to give us minus 171 and add together to be minus 1. And because if we have a look at this, 171, this number is divisible by 9. A divisibility test of 9 is if you add the digits together. So if we do 1 plus 7 plus 1, that's equal to 9. And that's in the 9 times tables. That's a multiple of 9. So that means that that number is divisible by 9. If the digits add together to be 18, it's divisible by 9. If the digits add together to be 27, it's divisible by 9. So a divisibility test to see if a number is divisible by 9 is you can add the digits together, and if that's a multiple of 9, then the number is divisible by 9. Okay, so I'm going to take this 171 and I'm going to divide it by 9, and I get that's equal to 19. So I'm going to try 19 and 9, one obviously being positive and one being negative. So I'm going to put the 9 there because 2x times 9, that'd be 18x, and I could put the 19 there. So we've got the 9 and the 19, they would times together to be 171. I will make one positive and negative in a moment. And then 2x times 9x will be 18x, and then we've got 19 times x is 19x, and we'll be able to get our minus x from those. So we want it to be minus x, we want it to be minus 19x, and we want it to be plus 18x, because minus 19 plus 18 would give us that minus x. So that's it, we've factorized that. And then here, the x will be equal to negative 9 here for this bracket, or for this bracket, we'd have 2x minus 19 is equal to 0. Add 19 to both sides gives us 2x equals 19, and dividing by 2 gives us x is equal to 19 over 2, or 9.5. So we've got our values for x. Now let's sketch our quadratic. So we've got minus 9 and 9.5. So minus 9 is over here somewhere, 9.5 will be over there somewhere. So minus 9 and 19 over 2, or 9.5. So we've sketched the quadratic, and we want to find where the quadratic is bigger than 0. So that's where this quadratic graph will be above the x-axis. So that'll be any value of x that is less than minus 9, or any value of x that is bigger than 19 over 2, or 9.5. Now if we go back up to the question, this was to do with a triangle, and here if we had a value of x that is less than -9, this space wouldn't exist. So that means that our values of x which would satisfy this will have to be values of x that are bigger than 19 over 2, or 9.5 bigger than 9.5. So that's x is bigger than 19 over 2, and that's it. And that's it. So in this video, we've looked at the video solutions to the quadratic inequalities practice questions. I really hope you found this video useful. It's been a fantastic set of questions to go through, so I hope you've enjoyed them as well. Perhaps the word enjoy is a bit of a stretch, but I really hope you found this video useful. If you have found it useful, please like the video and please subscribe to the YouTube channel. If you need any extra help on quadratic inequalities, go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 378. Alternatively, scan this QR code. But this set of practice questions, I really hope you found them useful. With quadratic inequalities, one of the things that I would always recommend the students is make sure you're doing those sketches, because it just really helps you find what region of or which values of x would satisfy the inequality. And that's it. So thanks very much. Cheers. Bye.